to within factory specifications. If the dwell reads low, adjust the screws out evenly to reach 30 degrees. If the dwell reads high, adjust the screws in evenly to reach 30 degrees. Final fine-tuning may have to be made once again by turning the idle air bleed valve. After all adjustments are complete, seal the idle mixture needle openings with a non-volatile, oxygen sensor-safe silicone sealer. Lastly, reconnect all vacuum hoses, reinstall the air cleaner, and test drive the vehicle for proper operation.
Now let's review the replacement and adjustment procedures on an internally mounted mixture control solenoid on a GM vehicle. Begin with the ignition switch in the off position. To avoid losing any small parts during this procedure, we suggest removing the carburetor from the engine before performing any of the disassembly steps. With the carburetor on the bench, proceed by removing the air horn. If the air horn gasket is damaged during this procedure, a new one can be obtained in a carburetor rebuilding kit. Remove the plastic filler block and carefully remove the metering rods. Using the special mixture control solenoid adjusting tool, turn the lean stop all the way in while counting the number of turns. Record the number of turns, then remove the lean stop from the carburetor. Remove the electrical connector retaining screw and remove the solenoid and connector together as an assembly. Compare the new and old parts to be sure of correct replacement. Position the new solenoid and electrical connector in the carburetor and reinstall the electrical connector retaining screw. Reposition the lean stop by turning it all of the way in and backing it out the same number of turns as was recorded earlier. Reinstall the metering rods and springs. Insert the mixture control solenoid plunger and using the special lean stop limiting gauge, adjust the lean stop as per instructed. Remove the plunger and reinstall the plastic filler block. On the air horn, remove the plug that covers the lean mixture screw and save it. Drill out and remove the rich stop screw plug. Drill out the retaining rivets and remove the plate that covers the idle air bleed valve. Reinstall the air horn on the carburetor. Follow the tightening sequence from a Haynes manual to prevent warping or leaks. Using the idle air float gauge, measure the mixture control solenoid plunger travel. It should be 4/32 of an inch. Adjust the travel by turning the rich stop screw in or out. Reinstall the rich stop plug using red Loctite to secure it in place. Use the shepherd's hook tool to measure and adjust the idle air bleed. Reconnect any vacuum hoses or linkages removed earlier and reinstall the carburetor on the engine. With the carburetor installed, check and adjust the idle speed and mixture control solenoid dwell with the engine fully warm. Refer to a Haynes manual for the exact procedures on your vehicle.
Okay, Jim, I've got a late model GM vehicle. We'll use that as our example. I'm driving down the road, down the highway as a matter of fact usually, and what happens is I step on the throttle and now I've got a bucking sensation, or it kind of hesitates as I'm going to take off. And I've also got an intermittent check engine light. What do you think?
Well, the fact that you've got a check engine light at all means you're going to have to pull the codes.
Okay, I've done that, and what I've come up with on my particular vehicle is a code 21. Where do we go from there?
Well, first of all, find what the code 21 means. You can refer to the manual that you use to work on the type of car that you have, such as this one.
Okay.
And in the code chart section of this book, we find a list of trouble codes. And code 21 in this case talks about a throttle position sensor problem.
Okay. So what we want to do then at that point in time is a quick 2-minute throttle position sensor test, and we'll show you how to do that right now. What we've got on the bench here is a throttle position sensor out of a carbureted vehicle. And really all a throttle position sensor is sort of like a rheostat, or your volume control knob on your stereo. As you push down on this volume control, it increases the resistance or decreases the resistance depending upon your vehicle, and changes the signal back to the computer. And it's got 3 wires that come out of it just like this. All TPSs have those 3 wires. Now testing it's easy.
It sure is. What we'll use is the ohm meter. And what I like to do is turn my ohm meter onto the 20,000 or the 20K scale, because that's a range that gives you a nice big spread of numbers when you're trying to test something that's going to cause numbers to change all the time.
Okay.
Now, since you have 3 terminals here in your throttle position sensor, and I only have 2 alligator clips, you have to remember which 2 to connect to. So take one lead, either the red or the black, it doesn't matter, and put it in the center of the 3.
Okay.
Then use your other lead to get into either one of the other 2 you want. So let's just do this one. Now we're connected to the center and the bottom terminal, and then we can observe the reading on the ohm meter.
Okay, what I'm going to do is actually press down on this little plunger here, and we're going to watch the reading on the ohm meter go up as I'm pushing down on the plunger. And we want to look for a real smooth transition of those numbers, and this one appears to be okay. You want to do that in both directions. The numbers will go up in one direction, back down in the other, and you want to do it relatively slow, because if you don't do it slowly, you could miss a bad spot in there.
You're right, and the important thing is the numbers should follow what you're doing. Nice and slow progression, up and down or down and up.
Okay, this one appears to be okay. So we've checked our throttle position sensor. That is okay. We've still got our code 21. Now where do we go?
Well, if that's the case, we know that there's something else wrong. So you can get into your manual such as this that talks about trouble codes and diagnostic trees, and we can actually find the diagnostic trees for code 21 and the throttle position sensor. So by following the step-by-step diagnostic tree, we're going to arrive at either a bad wire, a bad electrical connection, or maybe even a bad computer. But it's one of those things that's causing the problem on this vehicle.
Okay. Now, on the other hand, we've got another TPS here that we pulled off of a fuel-injected vehicle. Now, it looks a little bit different, but again, it's got our 3 terminal connectors on that. And why don't we run a test on this one, Jim, and see what we come up with here.
Once again, the ohm meter can be left in the 20,000 range. And take one lead, stick it in the center as you're doing.
Okay.
And then you're free to put that one in either of the other 2 you want.
Okay.
And here we have...
Let me see, I got her on there now.
Good. And here we have a reading, so go ahead and operate it just as you did before, and we'll see how this one does.
And we're going up slowly along with my movement, and we'll see. There it is. There's our open circuit, and now look at our resistance is changing again.
Now that's
we'll come up here, another open circuit.
That's quite erratic, isn't it?
Yeah, it sure is. So that's what's creating my bucking sensation when I'm trying to accelerate, and it's also giving me my check engine light, isn't it?
That's right. This is a bad one, and this is what it looks like. See, the ohm meter is picking up all those bad spots in there.
So hence the reason that you do want to perform this test very slowly, because if you don't perform the test slowly, you go too fast, you could zip right by those numbers and not actually even notice it at all.
Right. Replacing this part would solve your problem.
Sure. 2-minute test, you're down the road again.
Although there are many different styles of throttle position sensors, they can all be tested using the following procedure. Disconnect the electrical connection at the sensor. Set your ohm meter to the 20K scale. Connect one of the ohm meter leads to the center terminal and the other lead to one of the outer terminals. Polarity is not important. Slowly move the vehicle throttle through its entire range of movement. This is called sweeping the sensor. Watch the meter reading as the sensor is being swept. Any glitches noted during throttle movement denotes a failed sensor. This same procedure can be performed by using a digital voltmeter on the 20-volt DC scale and back probing the electrical connector with the ignition switch in the run position.
Replacing the throttle position sensor, or TPS, on either carbureted or fuel-injected vehicles can be easy with the right tools and our help. There are several different styles of throttle position sensors in use today, but all will resemble one of the styles shown and will be replaced in a similar manner. The tools needed to replace the throttle position sensor on a fuel-injected vehicle include one or more of the following: a set of screwdrivers, a 1/4-inch drive socket set, a set of small Torx bits, and a 10 megohm input digital volt.